Hi everyone, welcome to today's session of how to improve your player experience using the Azure PlayFab Data Platform. I am Nir Schlein, a software engineer in Azure PlayFab.
I'm Satya Baba, software engineer at Turn10 Studios.
And today we are going to talk about data. We'll start by talking about PlayFab PlayStream and how that can help you interact and react to data in real time. We'll then talk about PlayFab ingestion pipeline and how that powers up data connections, a new service offering from PlayFab that lets you power scenarios like batch processing and ad hoc querying. Finally, we will see a real-time, real-world example from Turn10 and how these scenarios used in the real world. Starting from PlayStream. What is PlayStream? PlayStream is a real-time event processing engine that lets you interact and react with your data in real time. PlayStream events can be generated either by PlayFab services or your game services and even your game client. Any event generated will go through PlayFab PlayStream, and you can interact with this event. A great place to start with PlayStream is the PlayStream monitor view. Any event that comes into PlayStream will show up in this view. For example, if a player logs into your game, you will see a player logged in event showing up in real time in this view. Starting to interact with your data, you have the event's real-time rules. You can configure real-time view rules to take action anytime events happen. For example, you can say, every time a player logs into my game, grant him with virtual currency. We support a certain list of built-in actions such as grant virtual currency, ban a player, send them a push notification, send them an email, and more. You can also trigger your custom events by running an Azure function custom rules. Similar to that, you have the real-time segmentation, where you can define segments over players. For example, you can have a segment of all the players that achieved more than 3,000 experience points. You can then trigger the same set of actions when a player gets into the segments or gets out of the segments. Last but not least is event history. Here you can see, visualize, and query your historical game events. So how does PlayStream work? At the core of it, we're using event hubs to stream anything that happens in your game. At the compute layer, we have Azure Kubernetes service that runs our logic. In our logic, we read all of your game events and distribute them farther down into more event hubs, which have more PlayStream processors to execute the rules that you configured. PlayStream guarantees at least one delivery for all your events, and we support standard and custom events. Another offering that we have is sampling, on which we would expand later, and that lets you have better control over your cost for ingestion. PlayStream is also backs up other services like telemetry, experimentation, player search, and segmentation. So what is this new data connections offering that we mentioned? Data connections is the integration point between PlayFab and your own Azure resources, such as storage account or Azure Data Explorer. It works by configuring your own destination and authorize PlayFab to write into this destination. Once that's done, we will start sending all PlayStream and telemetry events into your resource. For Azure Storage Account, we support Parquet format, and we also have a built-in retries that will keep retry for up to 24 hours in case your resource is unavailable for a short period of time. The evolution of data connections is quite interesting. A few years ago, we offered Event Archiver, but that came with certain limitation. It only supported S3 blobs. It did not support telemetry. The format was just JSON format, and that came with higher cost because blobs were small and not highly batched. A few years later, we offered Event Export, which started supporting Azure blobs and telemetry. but that came in higher cost because we had to ingest all events into Azure Data Explorer just to be able to export them later. Data connection is another step in this evolution. We now support Parquet format, and we all come with a lower latency and lower cost because you get much bigger blobs, fewer blobs, and low latency. Some scenarios of when data connections can be used. If you want to retain your data for longer retention, you can provision a new Azure storage account and container. You then authorize PlayFab into that container, and your events and data would start showing up. If you want to do your own reporting, you can set up a Synapse instance on top of this Azure storage and start building your own reports using Spark jobs. If you want to run your own ad hoc queries, you can trigger ingestion into Azure ADX from the generated blobs and start querying and interacting with your data on your custom ADX resource. How does data ingestion pipeline works? The data ingestion pipeline built on top of PlayStream and telemetry. We read the events from event hubs and using Spark structure stream to continuously batch your events and write them into a landing storage account using the Delta Lake format. We then use Azure trigger functions to distribute your data into your chosen destination. In this screen, you can see how to set up a new data connection. In your game, you go to the data section, select data connection, and then feed in your Azure resource ID, your Azure storage account name, the container name you created, and your Azure AAD tenant ID. As mentioned before, event sampling is another feature that lets you have better control over the cost of your event ingestion. You can set up per event level sample rate and sample out your events. You can sample up custom and standard event, and events are being sampled on the player or entity level based. That means if you have two different events sampled at the same ratio, you can still correlate and join them because the same players will be sampled on both of them. It's important to say that sampling happens before a distribution and after ingestion. That means it applies to all your data connections. It also means it does not apply to PlayStream. So you can still trigger 100% of actions for your events even when you sample them out.
I'm going to talk a little bit about how PlayFab, bring your own storage, enabled turn-10 data engineers to gather insights from the data. So turn-10 studios use data and derive insights from data to do multiple things. And one of them, improve player experience. How they would do it is, for example, the game can be slow in some regions or some platforms, so we use telemetry data to capture that information and diagnose like how can we improve the latencies, specific platforms that are affected by the issue and whatnot. Same thing with the crashes. Like when we launch a game, we closely monitor the crashes for the game and on different platforms, different regions, different player types, and whatnot. And we use data to drive insights and go about how to improve that experience by fixing those issues. On a larger scale, like understand players' behavior, right? So how the players are playing inside the game, so where are they struggling? Like which region they're spending more time in the game, and to see how we can improve that experience to get them from level 1 to level 2 or level N to level M, like next steps. So we do a lot of analysis on that, and we use telemetry data for that. Another example is click-through rates. Like we want the players to experience the best game possible. So we don't want them to spend a lot of time on menu screens and other options that they're toggling. So we monitor that, we see how much time they're spending it, and we see how we can improve that experience as well. And during the game development, our studio's quality teams pay close attention to the telemetry data that comes in and improve the exceptions that happens in the telemetry data, like out of bound values, averages, and whatnot, to improve the game, the values of the game as well. And one of the since these are live games, like there is also opportunities to do A/B testing, like how are players responding to certain features of the game, and we can assess the value of that using telemetry data. So we currently use PlayFab to process telemetry events into Azure Data Explorer, and we use a combination of Azure Data Factory and custom ETL to derive insights from the data. So we do ELT kind of experience in the Azure Data Explorer. With Azure Data Explorer and dealing with larger data sets, we do run into some limitations where dealing with these larger data sets. Azure Data Explorer, like the analysts, if they're running a lot of summary operations on long-term data assets, like they could run into some timeouts. And engineering had to also do some workarounds to deal with the limitations of doing ETL data transformations in that. So the diagram you're seeing on the left is how it would have been if there wasn't a bring your own service offered by PlayFab. So we had to push the data to Azure Data Explorer and then use continuous exports or some sort of mechanism to push the data into Azure Data Lake Gen 2, which is then used by Synapse Analytics to derive insights from. So that is obviously not ideal because there is an extra step in the middle which we would like to avoid. It would save costs, save latency on the data, save resources in terms of engineers actually maintaining those extra pipeline that's unnecessary. So the newer design would be using PlayFab data connections to directly push telemetry data into our Azure Data Lake Gen 2, bring your own storage. And so that completely avoided that extra hop in the data, which improved our experience in reducing the latency for our analysts who's going to use the data, and lesser costs because we don't have to maintain those exports. We don't need engineers to support those pipelines. And as soon as the data lands, we can immediately start analyzing using Synapse Analytics. It's going to save Turn Studio's cost in efficiency for not maintaining those pipelines. That's it for me. Take it away, Nir.
Thank you, Satya. Here are some useful links you can use for further reading, and thank you very much for joining us today.
Thank you.